Hello, today I am going to describe what cardiac output. Now, what is first of all, what is cardiac output? Cardiac output is the amount of blood that can be ejected from the heart in 1 minute. It is the amount of blood which is ejected from the blood, how it is ejected from the heart in 1 minute. That is cardiac output by each of the ventricles. It is the amount of blood that is pumped out by each of the ventricles in 1 minute. This is about 5 liters per minute. It is about 5 liters per minute, and it is the product of two things. One is heart rate and stroke volume. In other words, cardiac output is equal to stroke volume or stroke output into heart rate. Now, what is stroke volume? It is the amount of blood that is ejected from the heart per beat, per heartbeat. It is usually it is equal to 70 milliliter. So, if that is multiplied by the heart rate, that is about say 70 or 72, it comes to about 5 liters. That is the cardiac output normally is 5 liters per minute. Next, we come to the another important terms, two important terms. One is cardiac index, and the other is ejection fraction. So, first, cardiac index. Cardiac index is equal to the cardiac output per unit body surface area. Now we know that the surface area of our body is about 1.8. Actually, it is 1.5 to 1.8 square meter, and so cardiac index is the cardiac output per unit body surface area, that is equal to 5 divided by 1.8. So it roughly comes to about 3.29 uh, liter per square meter. So that is cardiac index. It is the cardiac output per unit body surface area. Next we come to ejection fraction. This is a very important parameter because it is measured in the intensive care units, and that gives us an idea about the contractility of the heart. So ejection fraction is there is a formula. It is stroke volume divided by end diastolic volume into 100. That is, it is a percentage of end diastolic volume that is pumped out in each stroke volume or each heartbeat. So the formula is ejection fraction. Ejection fraction or EF is equal to stroke volume divided by end diastolic volume into 100%. So that is the ejection fraction. EF is the ejection fraction, and that is equal to stroke volume divided by end diastolic volume into 100%. So it is the stroke volume expressed as a percentage of end diastolic volume, that is the ejection fraction, and its normal value is about 0.65. Normal value is 0.65, or rather it is 65%. Normal ejection fraction is equal to 65%, about 65%. If it is say increased to 80 to 90%, that is a very high ejection fraction, and that we commonly get during exercise. That is the physiological cause of increased ejection fraction. And while in heart failure, where the ejection fraction is much lower, it is about say 15 to 20%, like that. Maybe that indicates that the contractility of the heart, contractile power of the heart is greatly diminished. It is only It is only comes to about 15% of the end diastolic volume. So, what is end diastolic volume? It is the amount of blood that is present in the ventricles at the end of the diastole. So just before starting to contract, or just before the initiation of the systole, it is the amount of blood present inside the ventricle at the end of the diastole, and that is why it is called end diastolic volume. So that is about the ejection fraction, cardiac index, cardiac output. These are the definitions, and these you have to know very well, and these are common questions also. Now, next we come to the relationship between cardiac output and heart rate. This is a very important question, and what is the answer actually? Now, because cardiac output is the product of stroke volume and heart rate, so it simply appears that when the heart rate increases, the cardiac output will increase because it is a product of heart rate and stroke volume. But this is not always the case. So we can divide the heart rate in three ranges. One is below 50 per minute, another is 50 to 150 per minute, and the third range is when the heart rate is greater than 150 per minute. Now, first take up the first in the first case, the heart rate is below 50 per minute. So if it is below 50 per minute, heart rate is below 50 per minute, then that means the diastole is very much longer. Diastole is the one cardiac cycle is longer, and the diastole is very much longer. And if the diastole is very much longer, that means the heart is being filled with blood for a much longer period. So the stroke volume, the end-diastolic volume become much higher, and in the next bit, the stroke volume will also be higher, and so that the uh, product will so increase in spite of the fact that the heart rate is much lower, because the stroke volume becomes very much higher. So the cardiac output um, is actually higher. But if the heart rate goes below 50 per minute, then even when the heart rate is low, but even the if the stroke volume is even though it is higher because of the lower heart rate, their product is less than 5 liter per minute or normal cardiac output. So when the heart rate goes below 50 per minute, the cardiac output is lower, but between 50 and 150 per minute. Let us consider the case when the heart rate is between 50 and 150 per minute. In this case, the the heart rate uh, the heart rate becomes normal. When the heart rate increases, the diastolic duration becomes shorter, and so the stroke volume becomes shorter, but the product remains almost uh, constant. So again, to repeat, if between 50 and 150 per minute, when the heart rate is between 50 to 150 per minute, the heart rate may be a little higher, but in that case, the diastolic duration becomes shorter and the stroke volume becomes lower. So the product remains almost the same. So the cardiac output is in the normal range when the heart rate is between 50 to 150 per minute. But let us consider the case when the heart rate is more than 150 per minute. In that case, the diastole is very much shortened. Diastole is very much shortened, and so the end diastolic volume and therefore the stroke volume becomes so short. The stroke volume becomes so much less that the product stroke volume into heart rate or cardiac output becomes less than normal. So we see that when the heart rate is below 50 per minute or when the heart rate is greater than 150 per minute, the cardiac output is lower or less. But within 50 to 150 per minute, the cardiac output is more or less normal. So the curve is like an inverted, I'm not writing anything. It is like a U-shaped, inverted U-shaped curve. So that is the relation between the heart rate and cardiac output.